Okay, so let's try this IP tables trace. So on my worker load, I have a simple bash script here to load the netfilter log module and set the netfilter log for IP packet and add this IP table rule in the raw table and append it to the output chain. So right now I don't have any rule in the raw table. As you can see, nothing here. So let's execute this script. Okay, now we have a rule here to trace any IP packet to destination 443. Okay, so let's try this on the same worker load. Let's run this command and let's see in another window tail the kernel log. Okay, so this looks like a new packet, and we can actually read this guy. The first line here is so this packet hit the output raw table output chain with the source IP is the same as the destination IP 10.0.0.1, and this is a TCP packet with the source port this, destination port 443, and it is a SIM packet. So that's the first packet for TCP/3 with handshake. So notice the source IP and the destination IP the same, which I think is expected because this is a local telnet. So yeah. Okay, so the second log line here, it says again still in the output, and then in the raw table output chain, the outgoing interface. Notice the first log, the outgoing interface is the localhost interface, and this time the outgoing interface becomes the node interface. With the source IP still the same, but the destination address changed to the master node IP. Interesting. So the destination address has been changed. A DNAT has happened. But why there is no any IP table rules for destination address translation? I think because we are using the Linux virtual server as proxy mode, so Linux virtual server in the kernel will actually do the destination address translation from this guy to this guy. That's why you don't see any IP table rules being hit to do the destination address translation. Okay, so as you can see, Yeah, so even the TCP sequence number is the same for the SYM packet. So it's only did the destination address translation. So the third line here, again, it hit the filter table in the output chain. Okay, so filter table, it's so after the raw table, mango table, reroute, net, filter table. So it seems come to here. Let's check again. Let's check again. Filter table, same source IP, destination IP as master node IP, same packet, same sequence number. Oh, no, yeah. So here I didn't mention it. Here also the destination port also translated from 443 to 6443. Yeah, that's the job that is done by the Linux virtual server, the IPVS. Okay, so we hit kube firewall rule, a chain in the filter table. Okay, so still everything looks the same. This log line output policy to outgoing interface, the node interface, same source IP, destination IP. So it looks like there should be a packet sent out to the master node. How about let's run TCP down with this filter on the master node. Let's try that. TCP down. Remember, on the master node we also have the same node interface name, ENS224. That's the node interface in the master node and in the workload. So let's say host okay. So this guy already ended. Let's start it again. Now do you see something here? Okay, let's give a let's try telnet again. Okay, so you can see here on the master node, we can see the packet from 10.0.0.1 to master node IP. So the packet, the SYM packet actually has arrived on the at the master node, but with this source IP. So when the master node receives this SYM packet with source IP from this guy, what do you think a master node gotta do? Because master node has the same cluster services, and it also has the same virtual IP. Right? It has the same virtual IP. So if a master node sees a packet sourced from this guy to the node IP, I think the master node will sync this packet source from itself, and but the master node in the kernel, it didn't send this packet. It's from the workload. So I think the packet will be dropped by the master node because it looks like from this source IP, but it's actually not. It's from the workload IP. It's from the workload. So what's the problem here? I think the problem is here we should have a source address translation. Instead of this 10.0.0.1, this source IP should be the workload IP 7298. Remember, this is my master node IP 7293. My workload is 7298. So if the source IP comes from the workload IP, I think the problem will be resolved. So why we don't have a source address translation on the workload? Let's see, on the workload, we can actually run TCP down here on the workload. So we should see the packet if we telnet. On the workload, yes. See? So this is a TCP down on the node interface on the workload with the host filter, the services IP. So that's the problem. This packet should have been, the source IP should have been translated to the workload IP, then it would work. So how can we ask the kube-proxy or the kernel to do the source address translation? So let's check if we have any rules in the NAT table, because for source address translation, that's normally done in the net filter NAT table. So do we have any source address translation rule here? Masquerade is for source address translation. Masquerade. Yeah, I don't see any chain here or rule here for source address translation rather than this one. Why? because in the post routing chain in the NAT table, notice this masquerade. There's a comment here. Yes, so there is a rule here, like if any packet marked with this, do the source address translation. So in this chain, this rule, we will mark our packet source from any to any. So we should, but this could be mask chain is only referenced in the here. No, it's only referenced. Yeah, it's only referenced here in the kube services chain. But this reference is, it says if the source is not from 10.0.0.0, but in our kube services, the packet, the SIM packet, it is a source from the 10.0.0.1. So the packet will not match this rule. So it will not be marked by this flag, and the source address will not be translated. Yeah. So that's the problem. We need to resolve this.